Dear participants, in this particular session we will be discussing on experiment number 14 for section 1 IAVOC 105. Here we will be concentrating on development of logic gate operations using discrete components. We will be using diodes and transistors to perform logic operations. In our earlier experiments, we have seen that in order to perform logic operations like AND, OR, NOT, NOR and NAND, we have dedicated logic ICs. However, you will be surprised to know that even if we do not use an IC and use analog electronic components like transistor or diodes, we can generate such logic operation. This particular session is dedicated for such an experiment where we will be developing AND gate, OR gate and NOT gate using transistors and diodes. In this manual, I have already provided the adequate theory and the process that you have to perform. We will be using this trainer made by Luans Electronics Aurangabad, model number F07C for this particular experiment. And while performing the experiment, I will be discussing about the operation of the circuit definitely. And let us now try to see what are the features of this board. You can see that this board is driven by 220 volt AC. There is the main switch. When you put on the switch, you get the supply at the board. The supply has been lowered to 5 volt to suit the operational needs. You can very easily find that this is the backside of the board. There is the transformer to step down the AC, and there these 4 diodes, this capacitor, this regulator and this capacitor, they make the power supply part, and these are the transistors, these are the diodes that actually are connected to the terminals. You can see these are the terminals on which we will be making the measurements. These are the terminals, and these terminals are connected from these diodes and transistors only. You can see the transistors. So there is nothing to be worried, as we are unable to see any of the component on the outer side of the board. There are the diagram schematic mimics given, from which we can directly connect to the terminals. Okay, so let us now look at the another part, which is a very important block, that is the logic block. You can see here that these red terminals, they are capable of supplying 5 volt, while these black terminals, they are directly connected to ground. So this is the logic high terminals and these are the logic low terminals. Now we can connect these terminals directly to the terminals of these discrete components. So let us first try to understand the operation of this transistorized NOT gate. As we can see here that this is the base terminal of the transistor, to which we are to give either low or high signal, and the signal point is connected to the base through a resistance to limit the base current. On the collector side, we can find that the output terminal is connected directly to the collector and the emitter is connected to ground. We have got a ground terminal for our measurements, and the supply is given to collector. That means 5 volt is given to collector through another resistance R2. So let us now operate the circuit and see what is the observation. So I'll put positive terminal of the multimeter here and ground terminal here. Okay, and initially I will connect this base to ground. So I am applying a logic low signal and we can see the output is logic high. Now we will get the opposite. That means I will make the logic high to the input. You can see the input is connected to logic high terminal and our output is low. Now let us try to understand why this happens. You can find very easily that we are supplying a high or low signal to the base. So accordingly, the transistor will either remain in conducting state or in non-conducting state. Whenever we are supplying a high signal to the base, there is a base current, and because of that, you will be having a collector current. Now, when we are having the collector current, then the current flows through this resistance R2. If the Kirchhoff's voltage law is applied, then it can be found very easily that all of the voltage drop will be there across this resistor. And we are making our measurements across the transistor. So there will be no voltage across the transistor as the transistor is in completely conducting state. Now suppose we have made this terminal low. In such a condition, there will be no current to the base and definitely the transistor will not be conducting. So when the transistor is in a non-conducting state, then entire voltage will be developed across the collector and emitter. Therefore, we are finding such a result. That is, whenever we are applying a high signal to the base, the output is low. We are applying a low signal to the base, the output is high. Remember that this is the very circuit in which you are using the transistor simply as a switch. And whenever we are using some logic device, which is a low output current device to drive some high current load, then the load has to be connected in the position of R2. When it is high, that is your logic circuit terminal will be connected to the base, and when the output terminal of your logic circuit is high, your load will be active. When it is low, your load will be deactivated. So this is one very important application of the transistor as a switch. Now let us switch to the diode based OR circuit. Initially, let us see how the circuit has been built up. There are the two diodes D1 and D2. The cathode of these diodes have been combined together. We are measuring ultimately the voltage from this combined terminal, and this combined terminal is connected to ground through this resistance R3. Alright, now you can find that this circuit operates exactly as an OR gate. Initially, I will be connecting only logic 0 to both the anodes. Fine, and now let us invite the multimeter to the circuit. I will put it here, and there is some problem with this terminal, so I will be using this terminal T3. Remember that all the grounds are internally connected, so there is no problem if we use this ground for this measurement. Now you see that when both the inputs are at logic low, the output is at logic low only. Now I will make one of the terminals high. I will make the input terminal of diode D1, that is anode of diode D1 is connected to logic high. You can see now the output has become high itself. Now let us do the opposite thing. I will make D1 anode of D1 low and I will make anode of D2 high. you can see again, there is some problem I feel. Yeah, you can see again that the output is high. Now what I will do, I will take both the terminals to be high. You can see the output is high. That means the operation of an OR gate is verified. Let us try to understand the working of the circuit right now. You can see very easily that whenever we are applying a logic high to this point, that is the anode of the diode is forward biased because the cathode is connected to ground. When the diode is forward biased, D1 is forward biased because its anode is connected to 5 volt and the cathode is ground. This diode will be conducting. When this diode will be conducting, current will be passing through the resistor R3, and therefore you can see that whatever voltage we are applying here, since the diode is right now a closed switch, then the entire voltage will be reflected across resistance R3. Now, even if the diode D2 is not conducting, that does not make any difference because diode D1 is conducting and entire current will be passing through that diode only. In the opposite case, if this diode D1 anode is maintained at logic low and diode D2 anode is maintained at logic high, then the same situation will occur. And finally, when both the inputs, that is both the anodes, are kept at logic high, then both the diodes will be conducting. Therefore, again, the entire voltage will be available across this R3. So in this fashion, you can see that very easily we can employ two diodes to operate as an OR gate. Now let us concentrate towards the AND gate operation using the diodes. Let us see how the circuit has been built. You can see here we have just done the opposite thing. We have connected the anodes together. And the cathodes are working as two terminals of the AND gate. Now you see these connected anode terminals, they are finally hooked up to 5 volt through this resistance R7. And at this junction terminal we will be making our measurements. So let us connect our multimeter here. Let us get it here, and I will be using this ground terminal. This is working fine. And first of all, let us do one thing, that I will be making both of the inputs low. You can see I have connected this input terminal to logic low, and I will be connecting another input terminal to logic low. Now if such is the situation, you can see the output is logic low. Let us now make one of the inputs, that is cathode of diode D3 high and cathode of diode D4 low. You can again see the output is maintaining its low status. Let us go for the reverse condition, that is cathode of diode D3 is now logic low and cathode of diode D4 is at logic high. Again you can see the output is low. Okay, and finally let us go for high logic in both the inputs. Now you can see the output is having a logic high status. Let us try to understand that why this is happening. This function is just exactly the same to an AND gate. Okay, let us take up all the connections and try to find the operation. Let us see here that whenever we are making both of the inputs low, under such condition you can find that since both of them are low, all the current that is supplied from this point is passing through this point to ground, through the diode to this point to ground. Okay, therefore we are getting no output voltage when both the inputs are at low condition. Now see, if I make any of the input low and the other input high, then if suppose, for example, I will make this terminal A high and terminal B low. Now you see, for this diode D3, cathode is at higher terminal, whereas cathode is at high logic, whereas anode is also at high logic. When both the terminals is at high logic, and that is 5 volt, there is no question of conduction through this diode. However, this diode D4, since this terminal is connected to ground, that will be conducting. Since this diode will be conducting, entire current will pass through the diode. Again, we will have no voltage. Now see, when both the diodes, if you make the terminal A logic high and terminal B logic high, now the situation is completely different. The diode D3, it will not conduct, and diode D4, it will also not conduct, because both the cathodes are at the same potential as that of anode, because here we are applying 5 volt. Since anode and cathode are at equal voltage, none of the diodes will conduct. Under such a condition, whatever voltage is there, it will be reflected at this terminal, and that's why we are getting high when both of the terminals are high. We are getting high at the output when both of the terminals are logic high. So we can see with these experiments that definitely transistor, diode and diodes, they can be combined in such a fashion that they can be used as a NOT gate, OR gate and AND gate. As an assignment to you, I sincerely request that you try to develop NAND gate and NOR gate using diodes and transistors. Thank you for this session.